Hey algebra friends, here we are looking at chapter 4 and we're in section 4.5, graphing linear equations. Our vocabulary starts off with the idea of linear equation, and a linear equation is it's a little bit easier to look at them to kind of figure out what you got and what you don't got. So here's what a linear equation will look like. Oftentimes it'll have two variables, x and y, such that they are being added together. The variables are being added together. X plus y is equal to 7, or y is equal to 2x minus 4, or something like that. Even 5x plus 7y equals, 14. All of these are linear equations. What you want to observe in a linear equation is that each of the variables, usually x and y, sometimes two other variables, each of the variables have a power of 1. We could put an exponent of 1 here and not change the value of the equation, right? So the thing that we want to know when we're dealing with a linear equation is that the exponent value, when we look at an equation, we want to know that it's a linear equation. We want to know that we've got two variables. It is an equation, meaning there's an equal sign, and your x and y values are to a power of 1. So what's not an equation, what's not a linear equation, would be like 2x to the third power plus y equals 7. Not a linear equation because of this. Also, not a linear equation would be something like 1 over y plus x equals 3. This isn't a linear equation because of a subtle thing. Y right here is in the denominator, so technically, and this is something we haven't talked about, this can be written as y to the negative 1 power plus x equals 3. I know that this is weird, but the fact that y is in the denominator tells me that y is not to the regular first power, and that's the key that you need to make sure you keep in mind. The true definition of a linear equation is an equation that when you graph it, you get a line, but that's not something we've done a whole lot of, so I want you to be able to visually observe a linear equation. A linear equation in standard form, therefore, would be an equation that's in the form ax plus by equals c, where a, b, and c all refer to numbers that are, this little symbol means elements of the, and this capital I, written weird like this, integers. So basically I'm saying that a, b, and c have to be integers. Some textbooks, and I'm not sure if ours does, but some textbooks also specify that a has to be a positive number. So a has to be positive as well as an integer. So that's one of the things that we see with a standard equation. So examples of a linear equation in standard form would be 2x plus 3y equals 4. 5x minus 6y equals negative 19. All of these are examples of linear equations that are in standard form. So you remember I just said that linear equations are basically equations that when you graph them, you get a line, and we're going to talk about graphing in this chapter. So when you graph these lines, you'd graph them over the x and y axis, and we've discussed the x and y axis before, or the coordinate plane. And so I'm drawing two pairs of x and y axes, or coordinate planes, and what I'm going to do is I'm going to just graph a line like this. And I'm going to graph another line like this. And these two lines have what we call an x-intercept, which is where the graph crosses the x-axis, and a y-intercept, which is where the graph crosses the y-axis. So the x-intercept is exactly what you think. It's the point where the graph crosses the x-axis. And here's how this is usually going to look for us. When we're dealing with the x-axis, or the x-intercept rather, it'll be a point such that the y value of the point, look here, what's the y value? The y value has got to be 0. And the x value will be some x number. So you'll have some x value 0 where x is the x-intercept. And for the y-intercept, let's look where we put the y-intercepts. It's here on the y-axis or here along the y-axis? Well, we know when we're along the y-axis, our x value is 0, and we'll get some y value. So the x-intercept is some point x0 such that it is the point where the graph crosses the x-axis, and the y-intercept is some point 0y where the graph crosses the y-axis. Here in example 1, we're going to identify linear equations. So we're going to determine whether each equation is a linear equation, and if so, we're going to write the equation in standard form. Well, first of all, when I look at an equation, I'm going to walk up to it and I'm going to see, is y to the first power, is x to the first power, is it just a y, is it just a x, I don't want to see a y squared or an x squared, and I don't want to see y in the denominator or x in the denominator. And since I don't see that, I think I have a linear equation here. So the next thing they asked me to do is put it in standard form. Standard form is the form we talked about before. We need our x term plus our y term equaling to some constant term where, remember, a, b, and c are all elements of the integers. Specifically, a is a element of the positive integer. Element A is a positive number. And so to do that, I'm going to take this y equals 5 minus 2x. I'm going to move the 2x over to the other side because, remember, I want an x term, a y term, and I want it all to be equal to a constant term. So I'm going to get rid of the 2x by shifting it. I'm going to shift it by doing the opposite, adding its opposite. And I get 2x, let me make that 2 a little bit more beautiful, 2x plus y is equal to 5. And since the a value is an integer and it's positive, and the b value, I'm going to call that 1, is an integer, and this is an integer, I am confident that I've done the job. 2x plus y equals 5 is in standard form, and it is a linear equation. Let's look at this guy over here. This one's tricky because it looks like it's going to fit the bill. Here you've got x and y, and these are all to the first power, right? Technically, this is a little weird. This is not to the first power. If I multiply two variables together, if I multiply two variables together, I honestly bring it to the second power. So this is a little bit sneaky. This is not a linear equation. So I've got to press on from this example B. Coming down here to part C, I've got 3x plus 9y is equal to 15. X is to the first power, y is to the first power. There's no multiplication here. This looks pretty good. This is in standard form. Ax plus by equals c. Now the only thing I notice about this is that the coefficient of each, the a, the b, and the c value here are all divisible by 3. So I'm going to just let you know that you can write this an additional way. By dividing each term by 3, you would get x plus 3y is equal to 5. This is another standard equation, standard form of a linear equation, and as this is, and they're both correct answers. I don't really see any reason to do this, but this is another way of doing it. Let's take a look at this one over here. So we've got part D. Part D has 1/3 y is equal to -1. And on the surface, this looks a little bit like it's not a linear equation. Because early in the definition, I told you that the linear equation has to have an x and a y. So let's keep that in mind just for a second. I said generally it should have an x and a y. So you're thinking, okay, where's my x and y? Okay, so it's kind of here. You're not going to be happy. But if I had 0x plus 1/3 y equals -1, this is kind of legit because 0 is an integer, and the only thing we know about a, b, and c is that they've got to be integers. B isn't an integer. Is there some way I can fix it? And the answer is yes. So a linear equation generally has two variables that are noticeable that are there, but sometimes you can have a situation like this. And so yes, this is a linear equation. It is. I know. Don't be mad at me. So this is also another example of a linear equation. And Technically, if you had an equation with just x in it, that's also a linear equation. And we'll talk a little bit more about that when we look at the idea of slope. But let's get into this. So I've said that this is a linear equation. I added this 0x in here, which seems like a big cheat. But let's think about what it means and how we can actually write this equation in standard form. So if I'm saying this is a linear equation, I put 0x in here just so I can have it in sort of standard form or potential standard form. But I mentioned before that b has to be an integer, and this just ain't it. I have the power, just like I had the power to divide each term by a number, I can multiply both sides of my equation by any number that I want. It maintains equality, so I'm just going to do 3. Why did I choose 3? Because I know 3 would fix this fraction problem. So 3 times 0x is going to give me 0x again, because nothing changes when I multiply by 0, plus 3 times 1/3 gives me 3 over 3, or just 1. So I get plus y is equal to negative 1 times 3 is a negative 3. And so I have, even though it doesn't make you happy, I have written this in standard form. This is indeed a linear equation. Generally, you would see an equation like this just written as y equals negative 3. And a little hint, equations like this are horizontal lines, are going to be horizontal lines. And we'll talk about that again. So out of these 4, 3 of them were definitely linear equations that looked really different, and this one was not because of that xy multiplication there. So we'll talk a lot about different ways to graph, and one way that we will graph is by making a table, and it's an important and kind of a bare bones way of handling equations. When you make a table, you take the equation as it is, and you're going to look for xy pairs that work in the equation. And so one way to do it is just to choose random values of x and then figure out corresponding values for y. So I chose these values, and I'm going to do some work over here to figure out what the corresponding y value is. So negative 1, if I put a negative 1 in for x, and then I have to figure out what y is in this situation, I would say, well, negative 1 plus 2y is equal to 6. I'm going to move this over here because I got to get y by itself, you know, all that solving stuff. When I do that, I get that 2y is equal to 7, right? If I add 1 to both sides, then I'm going to divide both sides by 2. And when I do that, I get that y is equal to 3.5. So I get 3.5 here. When I plug in a 0 for x, this time, in this equation, I get 0 plus 2y is equal to 6, nothing to move over. What I basically have is that 2y is equal to 6, and if that's the case, dividing both sides by 2, I get that y is equal to 3. Again, I'm going to plug in for x, the 1. Notice I'm just plugging the 1 right in here. I'm plugging each value in, and I'm solving for y. When I plug the 1 in, I get 1 plus 2y is equal to 6. Move the y over, I get 2, not the y, but the 1 over, and I get y, 2y is equal to 5, and therefore, when I divide both sides by 2, y is equal to 2.5. So I get a 2.5 here. And finally, if I plug a 2 in, plus 2y equals 6. You guys see what I'm doing? Subtract 2 on both sides. I get that 2y is equal to 4, and therefore y is equal to 2. So now here I have a table of values that's going to help me graph. So I know you guys can do a far better job than I can because you've got some graph paper, but I'm going to show you, I'm going to draw my x and y axis, number my axes, and I'm going to plot these points. So when x is equal to negative 1, y is equal to 3.5. So I'll go up to 3 and I'll go halfway between 3 and 4 and put a dot there. Let me change the color. So I have that there. Then when x is equal to 0, y is equal to 3. So I get a point here. When x is equal to 1, y is equal to 2.5. So I go up to 2 and I go halfway between 2 and 3 and get my 2.5. Finally, when x is equal to 2, y is equal to 2. And as you can see, I got a straight line, right? Everything is in a beautiful straight line. And so all of the solutions to this equation would fall on this line. If you guys get an opportunity, you can pull up Desmos and try to practice this yourself and plug in this information. We did that the last time we were together. Let's take a look at another example, maybe in the next video.